All right, here we go. Here's your 4.1 first lesson from Module 4. We're going to start solving some equations. Notice that these are equations, not expressions, because there's an equal sign. Our goal is to solve for x or whatever variable that we're working with. And then we're going to look, by the end of the class, you're going to identify the difference between a linear equation and a nonlinear equation. So for number one, I got a lot of things that are keeping x from being by itself. I've got inside the parentheses, I've got multiplying x by 2 and adding 6. Outside the parentheses in front of it, which means I'm multiplying everything in the parentheses by 1/4. And then even behind the parentheses, I have -5. So I got to get rid of a bunch of stuff in order to solve for x. So the first thing we're going to do is we're going to do this little property right here. Now, it's amazing how many kids can draw the arrows, but then half those kids don't actually do the math that goes along with the arrows. So I need to multiply everything inside the parentheses by 1/4. And so since the number outside the parentheses is a fraction, I'm just going to make 2 over 1, and I'm going to make 6 over 1, just so that you're dealing with fractions, and a fraction times a fraction, just multiply straight across. So for number one, the first thing I'm going to do is my distributive property. And so I have 1/4 times 2 over 1. So 1 times 2 is 2. And now I'm going to reduce this in just a second. But for right now, I'm just going to write it like this. So 1/4 of 2 is 2/4. And then we're going to do the same thing with the 6 over 1. So 1/4 of 6 is 6 over 4. Minus 5. And I'm going to make 5 over 1. And then I'm going to make 9 over 1. Okay? So we have options. I can reduce these two fractions right here. Or I could just go straight to, I need to find a common denominator for everything. So either way it's going to work out. If you reduce those two, you're not going to get a different answer. You're just taking one extra step. So I'm going to leave these as 4s. So if my common denominator is 4, then I like my first two fractions, but I don't like this third fraction. Something over 4 is equal to 5 over 1. 20, right? Because 20 divided by 4 is 5. Okay. And then I'm almost done with all of my fractions where I have a common denominator. 9 over 1 is something over 4. 36. And if you're saying, I have no idea how we came up with those answers, like that person in the hall, 36 divided by 4 is what? 9. 20 divided by 4 is 5. Okay, here's the beauty of fractions. Because you'd probably much rather work with something that's not a fraction than something that is a fraction. You now have what is your common denominator all the way across the board? 4. So what you can do, since everything is over 4, you can just ignore the fractions. So we're going to drop the 4 on the bottom of everything, since 4 was the common denominator for every single one. Then now I can just work with integers. So I have 2x plus 6 minus 20 equals 36. Notice it's the exact same problem right here, but since I had everything with the denominator of 4, I'm able to just delete it. It's the same answer. So I'm going to combine my like terms right here. So underline those two. Those are my like terms because they don't have an x with it. They're just constants. So I have 2x. And then what is 6 minus 20? Those are like terms. What's 6 minus 20? Negative 14. Equals 36. My x is getting closer to being by itself because my goal is to solve for x. I want to get rid of minus 14 because it says 2x minus 14. How do you get rid of minus 14? You add 14. Two x, I still have the 2x there. This cancels out. So I'm left with, on the right side, whatever 36 plus 14 is, 20. I heard 20. Do we like 20? Wait, hold on. I think we're trying to get too far in advance. Let's add 36 plus 14. That's 50. Some of you guys are trying to go straight to your answer. And then you divide by 2. And so x equals 25. Now, you should always check your answer. Now, every one of you is going into an algebra class next year. There is no class other than that. So talking to Doherty teachers, they're saying, well, kids want to walk in and they say, oh, I wasn't very good at math in middle school. Is there something I can take lower than algebra? And there is no other class. Algebra is the first class you're going to take. So this is what sets you up for success in your algebra class. This is a linear equation. You should do this every single time, and my algebra kids do this every single time right now that are taking algebra. You take this answer and you plug it into your original equation and you make sure that it works. So I'm going to go 1/4 times 2x is no longer x. We just said that x is 25, right? Plus 6 minus 5 equals 9. If the left side equals the right side, then you're in great shape. What's 2 times 25? 50. What's 50 plus 6? Okay, so I need to go 1/4 of 56 minus 5. It better equal 9. What's 56 divided by 4? 14. So 14 minus 5. Does 14 minus 5 equal 9? Then you know you got your correct answer. So when you're doing an algebra test next year, or even a pre-algebra test this year, you're going to know before you even turn in the test whether or not you get the answer right, because you take that answer, you plug it back into your original equation. If it works, you did it right. If it doesn't, you did something wrong, so you go back and you look at your math. Okay? So I did that one with you, and that's probably the hardest one of today. We go to number 2, and it's much easier. My goal is to solve for y. It's no longer an x, it's a y. It's just a letter. What property do I need to do first? Distributive property. So draw your arrows. But guys, don't get so excited and happy with yourself that you just draw arrows and that's all you do. You have to go 2 times y. What's 2 times y? 2y. What's 2 times negative 6? Someone in my last class said, well, that's not a negative 6, that's minus 6. It's the same, right? Because minus 6 means plus a negative 6. So subtracting something means adding the opposite. So if you do see it as a negative 6, it makes it so much easier for you to say, oh, 2 times negative 6 is negative 12. Well, if my goal is to get y by itself, what do I want to get rid of first? I want to get rid of the negative 12, right? So I want to add 12 to both sides. So what is 22 plus 12? 34. And I'm almost done. Y is almost by itself. What is 34 divided by 2? 17. Notice that letter B says what? Check your solution. So we're going to take 17 and we're going to plug it into our original equation. So it's 17 minus 6. Because it was y minus 6, but you said y is 17. And so order of operations says, what is 17 minus 6 inside parentheses? What is that answer? 17 minus 6. 11. Well, what is 2 times 11? Well, does it work then? It works. So then you are feeling good about that answer. And so you would get that correct. Okay? Example 3. Mine's going to look a little bit different than yours. if you look at example 3, you have an A, a B, a C, and a D. You have 4 different word sentences, and then you have 4 boxes. And so what we're going to do is we're going to try to match each word sentence with the equation, and then we're going to try to solve each equation, okay? So by us doing this, we have to look at our 4 examples. So letter A says the sum of half a number and 6 is 22. The sum of half a number and 6 is 22. So which is the only one that takes half of a number? 3, right? Because if you're taking half of a number, what are you doing mathematically? You're dividing by 2, right? So don't put this in the box because you need to have room in the box. But right up next to number 3, you're going to put an A right there. So word sentence A goes with number 3, right on the top. Just put an A next to number 3. And then we go to letter B, and it says twice, this is a tough one, twice the sum of a number and 6 is 22. Which one is it? Equation 2. Well, look, if I look at equation 2, unless your equation 2 is different than mine, my equation 2 has a squared. Is that the right equation 2?
Yeah.
In your book?
Yeah.
So does this say anything about squaring anything for letter B? No, so we wouldn't want that. So that's the one that doesn't make sense at all. So it's either 1 or 3, but it says I want twice the sum of a number and 6. So I want to find a number and 6, and then I want to take twice of it. So which one is it? It's 1, yeah. So put a B next to number 1. Then we're down to C and D. Letter C says 6 more than twice a number is 22. 6 more than twice a number. That's 4. And then if we were thinking correctly earlier, this one talked about doing what to a number? Squaring it. So probably our definition has something, or a word sentence, the sum of the square of a number. So we've taken a number, we've squared it, and then we added 6, and we got 22. So this would be D. Okay, so now we're going to solve these 4. So what do I do? We just did a problem exactly like this. What do I do first on number 1? Distributed property. So I'm going to tell you right now, everything that we're doing right now, Module 4 and Module 5, when you walk into an algebra class next fall and you take an algebra class where the grade actually matters for you passing, this is the stuff that you're going to see. Okay? So what's 2 times W? 2W. What's 2 times 6? 12. And that equals 22. Well, how do I get rid of the plus 12? I subtract 12. And so if I do this correctly, I'm left with 2W on the left side. What is 22 minus 12? 10? Divide by 2? W equals 5. Now, there are a lot of times where you can check your work without even writing anything down. So you could probably, in your head, if you think W equals 5, plug 5 in right there. What's 5 plus 6? 11. What's 2 times 11? Did it work? Okay, that's how you check your... Now, they're not always going to be that easy, but a lot of times they are. So don't think it's a strenuous process of trying to figure out whether or not your answer was correct or not. Ooh, look at this. W squared plus 6. I have to solve for W. I'm going to get rid of plus 6 first. What do? Let's change colors. I want to get rid of plus 6. What am I left with on the left? W squared. What's 22 minus 6? 16. Have you ever seen in your math career, your 8th grade math career, have you ever seen a letter squared and what did you have to do with that? Think about Pythagorean theorem. You saw like an a squared or a b squared or a c.
I forgot the check mark is called.
Square root. There we go. So I just take the square root. So what is the square root of 16? Well, I heard an 8, but I heard 4. Now for you guys right now, that will work. But there are actually 2 square roots. Do you remember this?
Yeah, it's 16 squared.
You guys remember this?
The square root.
Oh.
A positive and a negative, right? Because a negative times a negative is a positive, and a positive times a... So really you have 2 square roots. Negative 4 times negative 4 is 16. Positive 4 times positive 4 is 16. If you just give me the positive, because we usually just assume the positive, then what's that?
What do you call that? Just like plus minus 4.
Yeah, both positive and negative. So as you get into algebra, when you start doing quadratics, you'll see that it has 2 roots, and so you no longer get with the line, you get into your quadratics, you have parabolas. Okay? Let's move down. I need to get rid of plus 6. How do I get rid of plus 6? So I'm going to minus 6. So I still have W over 2 equals, let's go down. Can I move down? I can. What is 22 minus 6? Not 14.
Sorry.
You're right, 16. All right, so now think about this. What's the opposite of dividing by 2? Multiplying by 2, right? So if I want to get rid of dividing by 2, I multiply by 2. So I'm just going to put a little 2 right here. Multiplying by 2 means I'll put a 2 on the top. And over here, I'm just going to put a little dot and a 2. Because it's saying some number divided by 2 is 16. So that some number is whatever 16 times 2 is. What is 16 times 2? 32. And then the last one, probably the easiest one. Need to get rid of plus 6. Subtract 6. What is 22 minus 6? 16. Divide by 2. W equals 8. And that's how we solve them. Okay? For the last 3, I'm going to do some modifications as we go through, and then we'll get to the exit ticket. But number 4, this is all I'm going to ask. Because every single one of those 4 could be the outlier, depending on what you're looking for. So this could be the outlier because it's the only one that has what type of operation? Subtraction. This could be the outlier because it only has how many terms? 1 term, right? Because this is a term, this is a term. So a term is separated by an addition or a subtraction sign. That one down there, bottom left, it only has 1 term. It's just 4x. This one could be the outlier because what do you notice about the exponent with the x? It's squared, so it's not going to be linear. And then the last one, this could be the outlier because you need to do what with these 2 terms right here? The 6x and the x, you need to combine them, right? So for the sake of time, this is the only one we're going to circle. So circle this one. And we're going to say it is non-linear. So if you ever see an equation or an expression where you have an x squared or an x to the third or a w to the third or an a squared, anytime you have an exponent other than 1, it's non-linear. So that is what, what's that?
It's going to be curved.
It is going to be a curve. Or if it's cubic, because someone asked my last class, if you have like an x to the third, it's going to look like this.
Drinking.
Okay? So that is, for you guys, that is your 11th grade year. You'll start working with cubic. Next year, you'll work with quadratic, which is a parabola, which looks like this. And you'll be working with these right here, which are called exponential curves. And if it's going up, it's a exponential growth. And if it's going down, it's exponential decay. Okay, but right now, all we're doing is linear. And so the root or the base word of linear is what? What word do you see inside of linear? A line. So if it's linear, it makes a line. If it's nonlinear, it makes one of these shapes. We're skipping 5. We're going to 6. So I want you to circle the right in this box right here. I want you to circle the linear equations. So if we ever have a variable where it's squared or it's cubed or it's to the 4th power, anything other than 1, it's nonlinear. We're not going to circle it. If you ever have just an x or a w or an a or whatever variable, and there is no exponent other than a 1, it's linear. So it says circle. Would you like me to circle this right here? Yeah, because that's going to be 2w plus 12 equals 22. So that's linear. How about this one? Is there anything where it's squared or cubed or anything like that? No. So that's linear. How about the bottom left?
No.
Why? Because x is to the what power? 3rd power. So that cannot be linear. What about this top one, second row? Or second column? No, that's a w squared. So that's not linear. What about your middle one in the second column? No, that's an x squared. So that's nonlinear. What about your bottom one in the second column? Yeah, because this is a 7x, this is a 4x. They're on different sides of the equal sign, but there are no exponents other than 1, so that's going to be linear. How about number, or I should say 3rd column, top one? That's linear. Because dividing by 2 is the same thing as multiplying by what number? Half. Multiplying by a half is the same thing as dividing by 2. This is a good one right here. Some people said yes, some people said no. If I go x plus x, is that x squared? What is it? It's 2x, right? So that's still linear.
I'm not even hitting your
Bottom of column 3, linear or nonlinear? I hear both. Anything other than x to the 1st? No, I don't see any exponents, so that's linear. How about top right?
Yes.
How about middle right?
Yes.
How about bottom right? No. So we have 4 that are non-linear. We have 1, 2, 3, 6, 8 that are linear. Last piece. Exit ticket. Making this large. What's the first thing we do? What? The line thing. You mean the arrow thing? What's that called? The arrow thing. Distributive property. Thank you for using the vocab. Distributive property. So 2 times x is 2x. What's 2 times 3? Equals 18. Subtract what? Subtract 6. So I have 2x equals whatever 18 minus 6 is.
Plus 3, not 6.
It's 12. Divide by 2.
6.
So you're telling me the answer is 6. And then it says for letter B, prove it.
Ain't that a 3 though? 2x plus 3.
2x plus 3. Did you multiply both?
Yeah.
So you drew the arrows?
Oh, you just didn't put the first part. Oh, that's not bad.
No, hold on. Say that again. So I went 2 times x, which is 2x.
I just you didn't put the first part, so like you didn't rewrite the actual problem.
Oh, I didn't read. Okay, I see what you're doing. Plug it in. 2. We told everyone said that x is 6. In parentheses, what is 6 plus 3? So Mr. Roden and myself have been talking, and as we're getting back into the pre-algebra phase where you have to write stuff down to set up problems, you're now going to have a written component of each test. So you're going to turn in your work, and if you don't have the work that supports your answer, you're not getting credit. So if you can't write this down step by step by step, you're just no longer getting credit because you must show your work to prove that you understand the process. Do I like that work right there in green? Yes, I do. That is it. So tomorrow, you're either taking the Module 3 assessment or watching the video for 4.2. Your 4.1 homework is up. You have everything you need, and we are ready for tomorrow.